Tell me, is this correct? In a group, I'm talking about a group. In a group, can I say that if A square equal to A, then A is equal to E? Yes, this statement is true. Yes, correct. Because if A square is A, then what you can do? You can write this A, you can write as A star E, because you know that A star E, this is equal to A for all A. For all A, this happens. This will happen for all A. Now I can say that now you can do the left cancellation because it is a group. So because it is a group, okay, so in a group you have left cancellation. So you can do the left cancellation because it is a group, remember. And finally I can say that A is equal to E. So this is correct. What about this one? What about this one? In a monoid, can I say the same statement? Can I say for monoid? Can I say in a monoid, if A star A is equal to A, then A equal to E? So the answer is no. The answer is no. You can take this counter example. Consider this set of natural number, comma, star, where A star B is given to you as max of A, comma, B. Max of A, comma, B. Now you can clearly see that what is it? Tell me, what is 5? What is 5 star 5? What is that? 5 star 5. What is that? That is 5 star 5 is 5. So you can notice 5 star 5. 5 star 5 is 5. But you can notice that 5 is not equal to identity element. Because what is the identity element here? Identity element is 1. Okay. So I can say that this is not equal to identity element. Correct. So this is the idea. Okay, so remember, in a monoid, we don't have these properties. So this point you should consider. Okay, remember, these properties we don't have in monoid. What are the common properties of monoid, comma, group? What is the difference between monoid, comma, group? Remember, here also you have unique identity. I can say here you have unique identity element. Can I say same thing here? Can I say that here also you have unique identity? Can I say? Yes, here also unique identity. Unique identity you have here also, here also. Okay, so this is both. But can I say, okay, can I say here you have unique inverse? Can I say here you have unique inverse for every element? Can I say unique inverse? Yes. But here unique, here inverse may not exist, because remember this is a monoid. So inverse may not exist. Inverse may not exist. Okay, for some elements. For some elements, inverse may not be there. Okay, for some elements, we may not have inverse. Can I say won't exist? Can I say won't exist? No, because every group is also monoid. Every group is also monoid. Remember, every group is also monoid. So in a monoid, I can say inverse may not exist for some elements. Inverse may not. Okay, may not exist for some elements. Next, what can you say about left cancellation? Can I do left cancellation here? Can I do left cancellation here? Yes. Here we cannot do left cancellation. Okay, here we do not have this left cancellation. So this left cancellation we cannot do here. So don't do a left cancellation here. Similarly, this right cancellation you can do. Don't do right cancellation here. Okay, so that is the idea. So understand the difference between monoid and group, because group is what? Group is monoid with inverse element. Monoid with inverse, and because of this inverse element, these things are happening. Monoid with inverse element. Because of this inverse, these things are happening. Remember, this left cancellation is also happening because of inverse. Because of inverse, this is happening. Because if you notice in a group, if you notice one thing, in a group, if I have like A star C equal to A star D, then because of this inverse, things are happening. Now, if I multiply with A inverse, now, because of this inverse, this is happening. Remember, the inverse is the reason. Now I can say that this will be E. This will be E. So finally, I will have C equal to D. So you can notice that this left cancellation that we have, this left cancellation you can do because of inverse. So because of this inverse property, these things are happening.